what are we going to think of secant x plus tangent x and multiply by that point A, secant x plus tangent x over secant x plus tangent x. Okay, this is pretty hard to think of to multiply inside. So usually when I have this problem, I just think of it this way. I just show you another way. It may be a little bit more complicated, but this, in my opinion, is more natural to think of. Secant is 1 over cosine of x dx. And I see cosine right here, right? I'll write this way. Integral of cosine of x over cosine square of x dx. The purpose is I want to have cosine of x dx, so I know myself. So I'll let u equal to sine x. So du is cosine x dx. So this problem becomes integral of du over cosine square is 1 minus sine square, so 1 minus u squared. Now you have to do something called fraction decomposition to solve the problem we haven't learned yet. So, I'm going to stop right there, but this is how usually I'll think of it. I can solve the problem too. Okay. All right, this is another formula, and then another one. Integral of secant cube of x dx, and this is more complicated. And you want to have a formula for this one. Let me think of the ways. We got to do integration by part, I think. Yeah. Let's see. Secant cubes, I do an integral of secant square of x times secant x dx. Okay. So this is my u, this is my dv. So if I let u equal to secant square of x, dv equal to secant x dx. Or maybe the other way around would be better. I think I would do it the other way around because I know that derivative of tangent is secant square, so let's do it this way. Okay. So secant x times secant square of x dx. Yeah, that's better. Then I have du is derivative of secant is secant x tangent x dx. If derivative is secant square, so v is tangent x. Okay, so this one equal to u times v, so secant x tangent x minus the integral of is that v du, right? This is u dv, so v du, so secant x tangent x squared dx. Okay, and this one is we have to do a little trick in here. Trick it as in secant x tangent x minus tangent square is, I know that 1 plus tangent square of x equal to secant square of x. So tangent square is 1 minus secant square minus 1. So integral secant of x times secant square of x minus 1 dx. You guys see the problem is getting harder, right? Okay, and this integral is what? I need some room to write, so let me erase that part. I'll rewrite in here. Integral secant cube of x gonna be equal to secant x tangent x minus integral. I'm gonna do distribution in here. I got secant cube of x minus with another minus become plus integral of secant x. Okay, I forgot the dx in here, dx in here, dx in here. Plus integral secant x dx. So you see what? Even though I still haven't solved for secant cube yet, but I got the secant cube on the left and secant cube on the right, I can group them all into the left hand side. So 2 times integral of secant cube of x is equal to secant x tangent x plus integral of secant x dx, and we just have it. Integral of secant x dx is ln of secant x plus tangent x, right? So we solve for secant cube. All I have to do is divide by 2, and don't forget to plus c at the end. Now I have the formula. And I claim those is the hard one to remember, to memorize. But it's pretty helpful when you work on a bigger problem, more complicated one. You go down to integral secant cube of x dx. Then you know that you're on the right track because you know the answer for that integral. Okay. The last type of trig integral that you see in this section is actually the simplest one, the easiest one among three. You're gonna see it's a problem like this. Integral, let me look. Of sine mx times cosine nx. Okay. Oh, I forgot dx. Or you can see something like integral of sine mx times sine nx. So same sign, but this is m times the angle. This is n times the angle. Or integral of cosine mx times cosine nx dx. Okay. So this type, the third type of trig integral you see is what? A product of sine times cosine of multiple angles. Okay. Those type of trig integral, you're gonna go straight forward to the trig identity that you learned. Let me just write down the trig identity that we have on this type of problem. Okay. Sine A cosine B is equal to 1/2 of sine A minus B plus cosine, plus sine plus sine is 2 times sine cosine, yes. Plus sine of A plus B, okay? The second one, sine A, sine B is 1/2 of cosine of A minus B minus cosine, yes, it's A plus B. You see the way we write it, we try to write what? And the angle, the difference of the angle first and then the sum. And I got sine, cosine, sine, sine. The last one gonna be cosine of A times cosine of B is equal to 1/2 of cosine of A minus B plus cosine of A plus B. Okay? So the tricky part, the hard part for this section is you really have to memorize some trig identities. Okay? And if you know it, then the math, the integral, the calculus part shouldn't be too hard. Okay? Alright, so let me give you an example on this type of problem. Say, let me use the first one right here. How about sine of 7x times cosine of this is 4x. Let's just make up. Okay, doesn't matter as long as a multiple of the angle x. So sine of 7x times cosine of 4x. I see what I have, sine times cosine. Then I'm going to use the first formula right here, where a is 7x and b is 4x, right? Sine of 7x times cosine of 4x. Then I can apply the formula right here. So let me write this up, okay? This is integral sine times cosine is 1/2 sine of the difference plus sine of the plus. So I'm going to want the 1/2 in front. Sine the difference, 7x minus 4x is sine of, let me write the whole thing for you first. Later on, you guys can just do a subtraction. 4x plus sine of 7x plus 4x is, well, 7x plus 4x is 11x. Okay, and then dx. And then you simplify more. You have 1/2. Be more precise. Parentheses right there. Okay, integral of sine 3x plus 1/2 integral of sine 11x dx here, dx there. Now you can have two separate integrals. You can integrate sine of 3x, let u equal 3x, you have the answer. Sine of 11x, let u equals to 11x, you have the answer. Okay? And of course, same thing for the other two. If you see sine times sine and you use the second formula, you see cosine times cosine, you use the third formula. You should have the answer. So let me finish up that problem for you. And I'm going to move on to the next section. Okay, so this first part right here, I let u equal to 3x. Then du is 3 dx. So this one becomes 1/2 in front. And then x dx is 1/3 du. Sine 3x is sine u. And then and dx is du. 1/3 of du is equal to dx. I have this. The second one right here, I let u equal to 11x, and I have du is 11 dx. I have the same thing, this plus 1/2, 1 over 11 integral sine of 11x is sine, a different u right here. Or if you don't like it, you do a v, but it doesn't matter in here. Sine u, and then dx is du over 11. Okay. I better use a different letter so to avoid any confusion. Okay, b right here. All right. So this one right here is 1 over 6. The antiderivative of sine u is negative cosine u. And this is 1 over 22 cosine v. And then don't forget to plus c at the end. This is negative 1 over 6 cosine of 3x plus 1 over 22 cosine of v here is 11x, and then plus c. Right. Remember the very first week of our course, I gave you the review on the U-sub technique that we learned in Cal 1. See that when we move on to Cal 2, substitution techniques keep carrying over and over in our course. So really, we need to practice them. Okay, let's start section 7.2 right here. Let me move on to the next section, 7.3. We'll be talking about trig sub, okay? Okay, so if you guys see this type of integral, then you can think of trig sub. However, let me make a claim before I'll show you the trig sub. Trig sub is not easy. It's hard. It requires a lot of steps whenever you deal with trig. It's usually not easy. Trig sub gonna be working. It's gonna be helpful. However, if you can think of other ways to solve the problem, then I will encourage you guys to think of other ways first, like U sub, regular sub, or integration by parts, or whatever method that applies to the problem. If it works, it's usually shorter than trig sub. But trig sub works, and it gets to the answer. Many other problems, none of the other methods gonna work, and you have to use trig sub. Okay, so let's start with the first type. You see some type of, say, square root of a squared minus x squared. Okay? Then I will let x equal to a sine theta, or x equal to a cosine theta. Usually I'll do sine because the derivative of sine is just cosine, where the derivative of cosine is negative sine. Okay? So it's got a negative, but either way it will work. Why does that work? Because if x equals, say, a sine theta, then x squared is equal to a squared sine square theta. So this radical expression right here is rewritten as a squared minus a squared sine square theta. You see that you can factor out the a square, square root of a square out, 1 minus sine square theta, and this is square root of a square times cosine square theta. Well, this is a cosine, right? If a is positive, cosine positive, you have it. You see, this is a little trick for this one. If you, one more time, if you see an expression of a radical, a square root of a square minus x square, a square could be 4, could be 9, could be any number, could be 5, and this is square root of 5 squared. Okay? Any constant minus x squared, you do this sub for me, or this sub. I encourage you guys to do the first one, but both of them are going to work. Okay? And the reason for this is going to have this one. Okay. Second type is square root of a squared plus x squared. So if subtract, you think of 1 minus sine squared. You have cosine, or 1 minus cosine squared, you have sine. Or if this is addition, you can think of what? Think of 1 plus tangent square. It's going to give you secant square. Okay? That's the key. So I'll let x equal to a tangent theta. Then x squared is equal to a squared tangent square theta. So this form becomes square root of a squared plus x squared, which is a squared tangent square theta, which is square root of a squared factor out, 1 plus tangent square theta, which is square root of a squared times secant square theta, and it's a secant. Okay? That's the second type. The third type is square root of x squared minus a squared. Now, the hint to think of this one is what? Still 1 plus tangent square equal to secant square. So really it's what? Tangent square is equal to secant square minus 1. What's the hint? So I'll let a equal to, I need to erase this, right? Let x equal to a secant theta. So x squared will be a squared secant square theta. And this one is square root of a squared secant square theta minus a squared. You see that I have secant square minus 1 come out. This is square root of a squared secant square theta minus 1. And you know that secant square minus 1 is tangent. So this is square root of tangent square. So a squared tangent square theta. And then you can solve the problem. That was a hint. However, this is just the very beginning. Okay? Let me give you an example. You see how much work you're going to put on a trig sub problem, trigonometric substitution problem. Okay? And that's the 3 main formulas that I want you to see to start with. Okay, so let's start with one problem. Let's see. It's too easy. Let me choose something that not so easy. So we have to do more work at the example. When you guys watch the video clip, the harder example you see, it's more useful for you to learn. Now let's start with example 3 right here. Let's example integral of 1 over x squared square root of x squared plus 4 dx. They ask you to evaluate that integral. Okay, so what do we see here? We see a square root of x squared plus 4, right? So it matches up with one of the 3 formulas that we just learned before. So x squared plus 4. I'll let x equal to, so this is plus, so I let x equal to, it should be like tangent plus 1, right? So I let x equal to 2 times tangent theta. You see why? X squared will be 4 tangent squared. So if you factor out the 4, you got tangent squared plus 1, and tangent squared plus 1 is secant squared. Okay, let x equal to 2 tangent theta. So dx will be 2 times, the derivative of tangent is secant squared theta, d theta. Okay, so this problem will become integral 1 over x squared will be 4 tangent squared theta. Okay, and then square root right here. X squared is 4 tangent squared theta, and then plus 4 inside. And what is dx? Dx is 2 secant squared theta d theta. You see, this section is called opposite of the previous section, right? On the previous section, we have a trig integral. We try to convert it back to non-trig function. Now what? We have a non-trig function. We do a trig sum. We bring it back to trig function. That's why I say it's going to be complicated. It's hard. But well, many times, many cases, this is the best choice when we do it. So let's try to simplify this. Okay. The thing inside right here, 4 square root right here, 4 out. We have what? Tangent square theta plus 1. Tangent square theta plus 1 is secant square theta. This is 4 square root of this. It's going to be 2 secant theta, right? So let's write step by step for you. This is integral. I'm going to write 2 secant square theta d theta on top. Bottom is 4 tangent square theta, and this one is square root 4 out tangent square theta plus 1. Okay, this is integral 2 secant square theta d theta. The bottom, oh, I can cancel out a 2 and a 4. Take out a 2 on the top. I got 1/2 in front. Price as much as possible, right? This is 2 right here. This is 4, so I'll cancel out a 2. And then bring the constant outside. This is tangent square theta. This is what? Tangent square plus 1 is secant square, right? And take square root of 4 secant square. I got 2 secant theta. Okay? We can simplify more. I can bring another 2 outside, so I got a quarter outside integral. Cancel out 1 of the secant theta. I got secant theta over tangent square theta d theta. Okay? Now, one more technique that you guys are going to see when you deal with trig function. That's beside the couple types that I showed you in the previous section, the 7.2. Another way to think of this type is what? Whenever you see a trig, you can think of convert everything back to sine and cosine. Okay? Because I never say that it's going to be working all the time, okay? But many times it's going to work. Right? Because for sine and cosine, the derivative of sine is cosine, the derivative of cosine is negative sine. So it's kind of going around, it's going to be working. So I try to convert things back to sine and cosine. I got a quarter integral of secant theta over tangent square theta d theta. Okay, this is a quarter. Secant theta is 1 over cosine theta. 1 over tangent theta gonna be cotangent. Cotangent is cosine theta square over sine square theta and d theta. Again, secant on the numerator, secant theta is just 1 over cosine. And then tangent on the denominator is reciprocal of tangent is cotangent, which is cosine over sine. Alright? So I can simplify some more. This is a quarter. Cancel out the cosine. I got cosine of theta over sine square of theta d theta. I see that this problem is solvable because I see what? I have cosine theta d theta right here. I'll let u, I didn't use u, right? So I'll let u equal to sine theta. You know why? Because the derivative of sine is cosine theta d theta. So if I let u equal sine theta, I got du is cosine theta d theta. Okay. See how long the problem is. We have to do a couple steps, right? And again, u sub is always coming back. So this one becomes a quarter integral of cosine theta d theta is du over u squared. This is a quarter integral right this way, if easier for you guys to see. Okay, and use the power rule, add 1 into it. Man, it's just gonna be u to